And let's begin. Here we go. Exercise 2A, reviewing angles. Let's write these notes. So, when you have an angle that is between 0 degrees and 90 degrees, let's have a look. I'm going to draw a diagram and I want you to draw it on the sheets as well. So when you draw a horizontal line, like this, okay, we always start 0 right here. Okay, so they'll be useful when you get to circular functions and all that. Right now, 0 starts here. So that's 0. When you go from 0 to 90, now 90 is exactly vertical. Okay, so you went from horizontal to vertical, that's 90 degrees. Now anywhere between, so let's say that angle there, so I start off 0 and I make this angle, this, there's a name for it starting with A, Ashwin. Acute, very good, write it down. So this is less than 90 degrees. Okay, so I started here and then I'm heading that direction. Okay, then what if the angles are exactly 90 degrees? That means, again, I'm going to draw the diagram starting off at 0. So here's 0. And then the direction I'm going is vertically up. Okay? Now it's drawn with a little box rather than a curvy angle. It's a nice square box. What is this angle called? Let's go with Tom. It's called right angle because that little box is equal to what degrees again? Can I please have? Let's go with Sully. What's that little box represent? 90 degrees, so write it in case you don't know, because a lot of students see the box, but they don't remember what it equals to. So right angle, 90 degrees. Next one. So I went from 0 and it went directly up, so that's the direction I'm going. That's 90 degrees, but if I went any more than 90 degrees, but less than 180, so this is what it looks like. So I started off at 0, and then I pass 90 degrees. So you can see I started here, and I'm going that direction now. Okay, so if I started here, I have to turn my body all the way to that direction. This angle is called, someone just called it out? Obtuse, very good. So this is obtuse. Then when you go from 0 degrees and they say you make a 180 turn, that essentially is going all the way the opposite direction. So if you were going left, you're now turning right. If you were looking forward, then now you're looking backwards. Okay, so this 180 turn, starting with S, is called, hands up? Straight, very good. So this is called a straight angle. Straight angle. Now, if it's a straight angle, wait, let me just do that again. So you're starting at 0, and you're heading this direction now. So you started here, and then now you turn all the way around the opposite direction. That's why the arrow is pointing that way. So the angle, which funny enough, a lot of students don't know the angle there. What's the angle? 180, literally says that. Okay, so 180 degrees, exactly 180 degrees. This here is a semicircle. Okay, for you to turn, you've turned a semicircle, half circle turn. That's a 180 turn. Okay, then you go to, well, if you go more than 180, more than the one angle, so you start off at 0, you go all the way around, and now it looks more something like this, starting off at 0, whoops, sorry, starting off at 0, but then you're going down this direction, so that's the direction you're facing. You see how the arc is getting larger and larger as we're moving? So the arc's getting bigger and bigger. This arc, what is that arc called starting with R? Can I please have, yes, Elliot? Reflex, very good. This is called a reflex angle. And then lastly, let's say I start off at 0 and I go all the way, nice full round, and I come back exactly the same spot. So if I started off at 0, I go all the way back to the same direction that I was. So it's nice, full circle. What is the name for this, Kyle? Revolution. What's the angle for revolution? If you do a full circle, what's the angle for revolution? Can I please have, let's go with Ashwin. 360 degrees, very good. So make sure to write that down. So full angle, if you can ever see anything that has an arc of a full circle, is 360. Anything that is half a circle is 180. And then anything that is right angled is definitely 90. Those are the key ones that I find that even though it seems obvious, a lot of students tend to overlook. So I'm highlighting them. 90, 180, 360. Okay? The next two. Let's see if you know this. If a pair of angles add to 90 degrees, it is called, starting with C, hands up. Yes, Colleen? Complementary. Now, when you spell this, it's not compliment. A compliment is like me flattering you. Complement is an E. Complementary. Okay, so that's called complementary angles if they add up to 90. Make sure to copy that down. And then if pairs of angles add up to 180 degrees, it starts with S. It is called, hands up, Elliot? Supplementary. Very good. That's called supplementary. The last one that you need to know, which we'll link into tomorrow's lesson, exercise 2B, when you have two lines that intersect, so you can see I've drawn two lines here, if they intersect, so this is an intersection there, they've got an intersection, the opposite angles, so this angle over here that it makes, which is an obtuse angle, and its opposite counterpart, so up and down, so if it's on top, bottom, the opposite angles are equal. So if this was 140 degrees, then the bottom must be 140 degrees as well. There's a name for this. What is this called? Starting with V. Leon. Vertically opposite. Write this down. It's called vertically opposite. That applies the same for this side over here. Now, out of curiosity, does anyone know? If this is 140, we can actually work out what that green region should be. What is the angle for green? Hands up. Colleen. Which is? 40. Now, why is this 40 degrees? I'm going to show you. Have a look. See this line I'm highlighting? What's the total angle in a straight line angle again? 180. So we know that from here to here, so if I started here and I turned around to this direction, that's 180 degrees. Now what's nice is you already know from here to here is 140. So the question is, how much more do you need to make a nice straight angle? You need to turn an extra 40 degrees. So you can see from here, if I was facing that direction, that's only 140. I need to face this direction, which is a nice straight line. That's why I need an extra 40 degrees to make 180. Okay, so but if this is 40, what should this be? 40 as well, because it's vertically opposite. They're directly opposite to one another. So this is also 40 degrees as well. So opposite angles are the same. This is called vertically opposite, and it's just based on the straight line angle. So every time you draw a straight line, 140 plus 40 is 180. 140 plus 40 is 180 this way, or 180 this way, or 180 that way. Doesn't matter, but there's always 180 for a straight line. Okay? All right, I'm going to zoom out. This is what you must know. So that's identifying. Once you're able to identify, you can then solve by using those properties. So here we go. Let's have a look at the first example. First example wants you to find the pronumerals, meaning what's the angle A and what's the angle B, right? Now, the only angle I know is 40 degrees. So that means that if I started here, okay, so I start here, this is my 0 degrees, and I do a turn, I turn all the way that much, so that's how much I turn. So that means I'm facing this way. That's 40 degrees from here to here. I went from there, and I face that way, that's 40 degrees. Now, I don't want to know, if I face this way and then I turn this much, okay, so if I'm turning from here and I face this way, I'm facing that direction now. What is the angle at A? Now we can look at a property and there's a clear little thing in the diagram that tells us how to solve it. Elizabeth. A must be 50 degrees. Why? Can I please have Tom?
Because as you can see, it's a right angle between 40 and A.
Oh, yes.
And 90 minus 40 equals 50.
Very good. So again, this is 90 degrees over here. If that's right angle, then that means this side is also right angle, because then that makes a nice straight line. 90 plus 90 is 180 for a straight line. So if this is 90 degrees, 40 plus A must be complementary. Remember, complementary means 90 degrees. So this here, I'm going to color it again. I'm saying that this corner has to be 90 degrees in total. So 40 plus whatever this is must be 90 degrees, right? So that's why Elizabeth knew this A value had to be 50 degrees. Boys, again, same room, same expectations. If you can't sit next to each other, move. Cool. Here we go. What about B? B 180, because clearly it's a semicircle. Sorry?
Well, if you look at the semicircle, you also know where you can look it at.
Yeah.
So you can tell because there's a square on the other side of it. That's a 90-degree angle. And then what's 40 plus 50 equals 90. So that means it would all have to equal 360.
Yep.
180 plus 180 equals 360.
Beautiful. That's exactly the mathematical part to it. If you didn't know that the semicircle is 180, exactly what Elliot just said. 90 plus 90 is 180, but we know a full circle has to add to 360. So that means if this is 180, this must be 180 by 360 minus 180. Okay? Very good. Let's do the next problem. Let's have a look at B. What can we say from B now? I can already see something. There's many ways to solve for A and B, but I can see something straight away. What do we see, Kyle? Why is B 55, Leon? Very good. So when you write your answers in the exercise book, I want you to draw the diagram. So it has to be B. It doesn't have to be a perfect diagram, but you need to draw what's currently happening. So you draw the diagram, you say, well, that's 55, and this is what B is, and this is what A is. Now, I don't want to see anyone writing B for question B, B equals 55. I don't want to see that. Okay, I want to see the reasoning. So the logic here is B is equal to 55 degrees because it is vertically opposite. Or you could do VA for vertically opposite. But I need to see a reasoning to your diagram. Because when you go back and revise on it, you can look back at this problem even after months later. You can look back and go, oh, yep. Oh, that's right. It's vertically opposite. That's why I knew it was 55. Okay, so whatever reasoning you come up with. There's obviously other ways to get B equals 55 as well. What about A? What must A equal to? Let's go with Halshwan. Is that your hand up or no? Okay. Do you want to have a go there? No? Lucas?
A equals to 125.
125. Now, Lucas said 125, so which is good. That is correct. But how did he get 125? Can I please have Kyle?
180 minus 55.
Very good. Again, this is a nice straight line. Can you see that's a straight line? So that means if this is 55, this entire angle, if I went from here to here, that's 55, then I need another 125 to make 180. Okay, and if you couldn't do that arithmetically in your head, you could have done 180 take away 55, and that would have gave you the leftover, which is 125 degrees. So that's why we know 125 is A, but what's the reasoning? What do you write? There's two possible answers you can write here. What's the reasoning? To remind yourself. You could write 180 minus 55 because it's straight angle. So you can write because it's straight. Or what's another one? Supplementary. Very good. So you know it has to add up to 180. So either straight or supplementary. This is what I'm looking for. So in your exercise book, you've got the question. Diagram drawn. Whatever method you chose. So you could do 180 minus 55 or some of you will do it in your head. But I need a reasoning. Because a lot of this at year 7 and 8, you can do it in your head. But the reasoning is key. Because if you can do the reasoning, then when you start doing enrichment and the crazier problems, that's when you can decipher what you need to solve. Okay? A lot of students can do it intuitively, but not really understand what they're doing. All right. Let's look at the next example. Flip over to the next page. Let's have a look at example 2. This is from your textbook. I'm doing question 7 now, problem solving. Let's look at 2A question 7. Flip over, boys. Make sure to flip over. We're on the next page. Oh, you're doing this problem? Yeah, I'll pick someone else first. Let's go with, who would I pick? Liam. Got any ideas on how you might solve this problem? Beautiful. Okay, very good. So, again, Liam noticed there's a straight line. And again, we know that angle in a straight line, remember this, whatever A is, I don't know. Whatever that is, plus whatever this extra A again, I don't know. But I know that if I add all the A's together, so this bit, plus this bit, plus this bit, that gives me a full direction, which is a straight angle. So that means A plus A has to give me a straight angle of 180 degrees. But if I do A plus A plus A, that's 3 groups of them. So we can just say 3 times something has to equal to 180. And Ashwin, what would that equal to? You don't know? Okay. Oh, 60. You can, if you're not sure, you can do a guess, 3 times something, or you could do the opposite of times, which is divide. If you said, instead of 3 times something, you could do 180 divide 3. So 180 divide 3. 3 goes into 18 6 times, and you got the 0. Okay, so that's how you can get 60 degrees. So this is a problem solving one. The layout is key. So diagram, this is supplementary or straight angle. And then I've worked out what A equals to. So question, method, answer. Next one, C. C looks a bit funny, but same concept. Bo, you want to have a go?
Yeah, it's vertically opposite, so it's 70 divided by 2, which is 35.
Oh, so beautiful. I love it. So what we notice is A and A, if I add these 2 angles together, I don't know what it is, but I can see that in the diagram, here's my 2 lines. Remember, vertically opposite needs 2 intersections. That angle up here is 70. That means the bottom angle must be the same as well. But that means, just like what Bo said, if they're vertically opposite, A plus A, so these 2 angles added together, must also be 70. But A plus A is 2 groups of A. So really it's just saying 2 times something or double of something gives you 70. This is why Bo did divide by 2, because he said let's halve it to get them individually equally. So divided by 2, and he said it's 35 degrees. Pretty good. Last example for today. This one should be easier. Last one. What do we do here now? Kyle? Okay, so he's already jumped to the point. Why 180? Again, this is a straight line. Always look for the straight line. It's a key thing. So I've got a straight line. I can see that from here to here is 2A degrees, which I don't know. But if I add it on with 3A, so if I add it on next to 3A, so 2 groups of A plus 3 groups of A, I know that that's a straight line angle right there. So it must equal to 180. Now for some of us, we look at that, we're like, what does that mean? We'll write it out. 2 groups of A just means A plus A. 3 groups of A just means A plus A plus A. If you add them all together, I've got 5 groups of A now, so that's why he said before 5 times A. So 5 times what gives you 180? If you can't figure it out, do the opposite of times. Instead of timesing it by 5, you can work out for A by dividing 180 by 5. Okay, so you can do that on a calculator if you're not strong with your division, or you can do it short division so far because you learned chapter 1. So here's 180, 5. 5 goes into 1 0 times, 5 goes into 18 3 times, remainder 3, and yes, whoever said 36 before, that is correct. So that means this is 36, A is 36, so double of 36 is 72. And then triple of 36 is, what's that? 108. So 72 plus 108 gives you a nice, yeah? Because we know A, the angle A is 36. So if you did A plus A plus A plus A plus A 5 times, it should add up to 180. Okay? All right, team. That's it for today. That's exercise 2A. That question is question 7, problem solving. You want to work on fluency first before problem solving. Here you go. I'm going to stop the video.